Welcome to the Planet of Maths channel. In this episode, we'll talk about solving the system of equations using the substitution method, and this is part 2, so it's like a second level. In the substitution method, we want a situation like x equals something or y equals something. So we want only x or only y here. In this equation, we don't have such a situation, and we also don't easily find such a situation because there is no weak point. Next to each unknown, whether it's x or y, there's always a number. So this is a bit more challenging situation. But if we take a closer look at the first equation, here we can notice that all three numerical coefficients can be divided by 2. I'm going to divide everything by 2. So here 2, and here 2. And what will I get from this? Here I'll get 3x, and from this the 2's cancel out, leaving me only y. And from this, I get just 1. And here it's already much better because here we have a y next to which there's no number. Well, there's an invisible one, but there isn't any other more difficult number. And that's the weak point of this system of equations. We can calculate this y here now. We just need to subtract 3x from both sides of the equation since I just don't want these 3x here. Here, these 3x's cancel out, leaving me with just y. And here I have 1 minus 3x's. And this is already a good situation. Here I have found y, which means I can put this expression wherever y is. I'll put it in parentheses here. I calculated all this from the first equation, so now I'll move on to the second equation. In this second equation, instead of y, I'll be able to put this. So these two x's don't change. Plus, 3 doesn't change. Between 3 and y, there is multiplication, and instead of y, I put the parenthesis. 1 minus 3x's, that's what I calculated here, and it equals 10. I don't want a parenthesis here, so I'll rewrite the 2 x's and multiply the 3. First, 3 times 1 is 3. And then 3 multiplied by negative 3x gives us minus 9x. And all of this equals 10. I'll reduce the x. 2x minus 9x is negative 7x plus 3 equals 10. I don't want to have this 3 here, so I'll subtract 3 from both sides of this equation. I'll subtract 3 here, and I'll subtract 3 here. The 3's cancel out, leaving me with minus 7x, and 10 minus 3 is 7. So now all I have to do is divide everything by the number next to x. So I divide by minus 7. Minus 7 appears down here, and here as well. And then it turns out that x will be equal to 7 divided by negative 7, which is negative 1. So I've already calculated x. Now we need to calculate y. So I'm going back to this equation marked with a star, and now I substitute this number for x. I've got y. Here I write 1 without the parenthesis. I write minus 3, and here instead of the x, I'll insert negative 1, so it needs to be in parentheses. I'm writing down 1. Here I have negative 3 multiplied by negative 1, so I get a positive result 3. So y equals 4. And that is the solution for my example A. In example B, again, it isn't an easy situation because with x's and y's, there's always some number. Additionally, we have decimal fractions, which makes it an additional difficulty. So I'll do it like this. I'll take the top equation, and since I don't like fractions at all, especially decimal fractions, I'll just multiply everything by 10. And here it will be times 10, here times 10, and here times 10. From this first multiplication, I'll get 2 x's. From the second multiplication, I get minus 1y. And from this, I'll get 7. And now the situation is a bit better. I only have the 1 next to y, and that's good. Now these 2 x's, I don't want them here, so I subtract 2 x's from both sides of the equation. These 2x and these 2x cancel out, leaving me with minus 1y, and here I have 7 minus 2x. I don't want to have this negative 1 here in this spot, so I'll divide everything by negative 1. Here I divide by minus 1, here I divide by minus 1, and here I divide by minus 1. This division gives me y. This division gives me negative 7, and in this division, there are 2 minuses, so it gives a positive 2x. And at this point, I calculated y. I'll mark this equation with a star. I calculated this from the upper equation, So for the lower equation, I'll be able to substitute this entire expression for y. I substitute in place of y right here. Minus 6x's stay the same, plus 4 stays the same. Here there is multiplication, and here in parentheses, instead of that y, I'll insert what's here. The y is gone, and instead, it's negative 7 plus 2x's. That equals minus 11. I'll multiply the parenthesis now. Minus 6x's stay the same. 4 times minus 7 is minus 28. 4 multiplied by 2x's equals 8x's. Equals minus 11. I reduce x's. Minus 6 plus 8x results in 2x. Minus 28 equals minus 11. I add 28 to both sides of the equation, plus 28 here and here. When reduced, it's 2x equals 17. I divide everything by 2. So here's a 2 at the bottom, here's a 2 at the bottom, and that means x is equal to 17 over 2. 17 halves is equal to x, so now I can calculate y. I calculate y here using the equation marked with a star. Y is equal to minus 7 plus 2. And here it's multiplication, so I multiply. And instead of x, I put this fraction, 17 over 2. I rewrite the minus 7, and here I have to multiply. And this multiplication will be cool because 2 wholes are actually 2 over 1, and then the 2 and the other 2 cancel each other out. So I'm left with just 17. Therefore, y equals 10. With x, we could still factor out the wholes. 17 halves is 8. 8 times 2 is 16, which means I still need one more to get 17. This is the solution to my system of equations. In example C, I have a challenging situation because both equations look quite unsatisfactory. I'll deal with each of these equations separately. Let's look at the first equation. 1.5x subtract 1.5y equals 9. This equation is not cool because there are some numbers with x and y, and it's 1.5. Here you might want to multiply this by 10, but you don't need to multiply it by 10 here. Just multiply by 2, because these fractions are nice fractions, they're halves. Here I multiply by 2, here I multiply by 2, and here I multiply by 2. Multiplying 2 times 1.5 gives me 3x, and multiplying this gives me 3y. And from this multiplication, I get 18. And here I also notice that since I have a 3, and an 18, all of this can be divided by 3. Here I divide by 3, here I divide by 3, and here I divide by 3. Here the 3's cancel out, it results in x. Here the 3's cancel out, giving a negative y, and 18 divided by 3 equals 6. And this equation is already quite a cool equation. I would like to have a situation where x equals something or y equals something. So here I will easily solve for x. This negative y is a bit trickier, x is simpler. We add y to both sides. Here the y's cancel out, leaving only x, and here we have 6 plus y. That's a nice equation. I underline it and mark it with a star, because I'm definitely going to use it again. Now I still have to deal with this lower equation, this equation. Here it is like this. First of all, we don't want parentheses, so I do this. I copy this, I copy that, and minus 3 times y gives me minus 3y. And then minus 3 times 1 gives us the result minus 3. This x is definitely not on the right side, so I'll add x to both sides of this equation. Here will be plus x, and here will be plus x. Then I get 2x from this, and on this side I'll only have minus 3y subtracted by 3. And now the situation is quite pleasant. Now I can actually make a substitution. Since I know that x is equal to this amount, I can replace x everywhere. I can put such a parenthesis here. In place of this x, I'll substitute this bracket. I have 2, here it's multiplication. And in the parentheses, I put in this expression, 6 plus y. Nothing changes here for me. I multiply 2 by everything inside the parentheses, which means 2 times 6 is 12. And 2 times y is positive 2y. To sort it all out, I add 3y to both sides of the equation. But also subtract 12. Then these 12's cancel out. I'm left with 5y after adding 2y plus 3y. Here the y's cancel out, and it comes out to negative 3 minus 12. That is negative 15. I divide everything by 5, so here by 5 and here by 5. That gives us that y will equal minus 15 divided by 5, which is minus 3. So y is equal to that. And now I'm calculating x from this equation marked with a star. X will equal 6, without the parentheses. Add minus 3, which means subtract 3, and that means x is equal 3. End of example C. And the last example in this video, example D, which is quite a special example. In this example, we do not have any weak points. Next to each x, there's a number, and next to each y, there's also a number. Additionally, it won't be easy to find the weak spot here by multiplying or dividing something. But here we can do one thing. If I take the top equation, and I'll subtract 5y from both sides of this equation, it will make it that 2x's equal negative 10, subtract 5y. I'll underline this and mark it with a star. And that's because in the second equation, I also have 2x's. I don't always have to bring it to the form of x equals something or y equals something. This time, that rule won't apply here. Since I just calculated this, it means I can replace 2 x's with a such expression. And here in this second equation, I have exactly 2 x's. So the place of these 2 x's, I'm putting in what I got here, so negative 10 subtract 5y. Subtract 3y as well, and it equals 6, which I just write down. Now I can reduce y's. I have negative 5 minus 3, so it will be minus 8y, which equals 6. I don't want this 10 here, so I'm adding 10 here and adding 10 here. 10's cancel out. We get minus 8y, which equals 6 plus 10, making 16. Divide everything by minus 8. Minus 8 at the bottom, minus 8 at the bottom. And it turns out that y will equal 16 divided by minus 8, which is minus 2. And I have y calculated. To calculate x, we substitute the number minus 2 for y in the equation marked with a star. So we rewrite 2x. I no longer include minus 10 in parentheses. I keep the minus 5, and here I put, since there's multiplication, I put times, and in parentheses instead of y, I put the number minus 2. 2x will equal minus 10. Then we have to multiply negative 5 by negative 2, which gives us a positive 10. Negative 10 plus positive 10 gives us 0. So I divide everything by 2. And it turns out that x is equal 0 divided by 2, which is 0. And that's the result for my example D. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.